这么写的呢？就是简单的水路流。
Hello.
不是这么写的吗？肯定不是啊，怎么写啊？
Can you see the screen?
你看谁这样写？这个啊，就是一个路由，它的一个方法嘛。对啊，对啊，那个方法，他们就是个方法，没错啊。人家的方法跟你的方法是一样的吗
Okay. So
不一样吗？
Sergey and Claudius are here, and Alex will be absent. So let's just start. Okay, so today I'm gonna talk about the encoding digest and encryptions. Why I picked this topic is because there's often significant confusion around difference between encryption, encoding, hashing, and so on. I find people always got confused around this concept. So what is digest? What is encoding? What is encryption? Encoding. I found this picture as well clarified what is encoding. So just forget about computer science. If you, as a human being, you want to express your idea, like you want to tell somebody that I want an apple, what are you going to do? First, that apple should be in your mind, in your brain, and you encode your idea to language, I mean voice, then transport your voice to somebody else, and somebody else, in this picture, let's say B, he should be able to decode your voice, and then he can understand your idea. So this is the basic idea of encoding and decoding. It's for transportation of messages. So in computer science, we use 0 and 1 to transport informations. The typical encoding is ASCII. So as you can see from this table, I think around 128 characters are saved in 1 byte a binary code to transport the information in binary code. So ASCII is so information is encoded to ASCII. And this is another ASCII 85 code. The idea behind it is ASCII 85 uses 5 bytes to represent 4 bytes. For base 64 is using 4 bytes to represent 3 bytes. That's a little bit lower efficient than ASCII 85. So from this illustration, you can see that if here is 4 bytes represent MAN, which is ASCII 77, 97, 110, 32. This is the binary code. So in ASCII base 85, ASCII 85, there are 5 bytes. Each one is a radix 85 base. So why 85? Because 85 is the smallest number which can be used in 5 bytes, covered the 4 bytes binary code. Okay. Base 64, we use it in front-end development, like encrypt a image to some ASCII human-readable code. So base 64 is using 4 bytes to represent 3 bytes binary code. And what else? It can Morse code, and this is Roman numerals. They are all kind of encoding and decoding. So encoding and decoding is not to make somebody else hard to understand or hide something from somebody else. It's just a protocol, or based on, so we base understanding how to encode and decode. It's just used to transport informations. So this is encoding and decoding. So what is digest, or aka hash? So hash is, I think digest is a better name, because you can see from this, it's just like a filter. So you put your plain text or information into this filter, and it will be digested and produce a unique fingerprint. So digest or hash is used for information integrity. It's always used for checksum, to check whether the information is modified by someone standing in the middle. This is the main purpose of digest. Just like encoding and decoding, it's not trying to hide something. It's just providing a way for you to check the integrity. So MD5 is a common use of digest, but you see I labeled it obsolete because there's way to revert it. So theoretically, a message can be digested to a fingerprint, but this is a one way, right? The output cannot be reverted back to the input. But MD5 is not secure. There's some way to, we call it a rainbow table. You can revert from output to input. So it's not secured, it's obsolete. We're not suggested to use it. The basic idea of MD5, or most of the digest algorithm, is they will have an initial state. For MD5, it's 128 bits state, and this is the original message. The message will be split into chunks. Every chunk has 512 bits, and the algorithm will iterate the chunks and do some function or mapping with the initial state. I'm not going to go into the details. It's easy to search in Google. So I just want to introduce the basic idea. So finally, after a couple of operations, couple of rounds, the initial state will be a fixed. I mean, the length of the initial state is always 128, but the content is changed. so this is the basic idea of digests. This one is much safer, and it's suggested to be used for hash password. I forget how we hash password in OV8. Maybe it's bcrypt. Yeah, so for bcrypt, the difference is every time you digest the same message, it will output the different fingerprint. As you can see from the output, it has several solid. The first one is algorithm, this one is a cost, and here is the sort. So every time it generates a random sort to digest the the original text. So so I'm going to show you some demos here. In Golang, this is the demo for it. You have a password here, and you run the generate from password, and this is the cost. Just run it. Crypto. Okay. So the hash password is here. It's like this format. If I run it again, you can see that they're different because the sort is different. So for the typical use is we save username, user ID, and hashed bcrypted password in database, and then call the compare hash and password function. If there's no error, that means user keying the correct password. If there's errors, then the password is invalid. So if I change this password to to 123, which is different from ASCII password. You'll see the error. Hash password is not the hash of the given password. Then user is not authorized. Okay, so this is the typical usage of bcrypt. Another one is SHA-O. This is the main idea is the same. You can see the benchmark with the MD5. They use these operations to mutate the initial state. The initial state for MD5 is 128, and SHA-3 is much larger. So SHA-2 is still safe, but SHA-3 is more efficient maybe. I'm not dive deep into these two. So if you have interest, you can do that. Okay, so this is a message digest. It's nothing about hide something. Once again. Okay, encryption. So encryption is something interesting. Encryption, as you can see, I have a key here. That means you want to hide something from somebody else. Only if that guy has a key, he can read my message. So this is different from digest and encoding. Encryption transforms data into another format. in such a way that only specified individuals can reverse the transformations. It uses key which the key is to keep secret in conjunction with the plain text and algorithm in order to perform the encryption operation. So as such, the ciphertext algorithm and key are all required to return to the plain text. Sorry. There are two kinds of encryptions. One is symmetric encryptions. The main idea is if I want to encrypt some plain text, I will use a key to encrypt it to some magic words. And if you want to read it, I will give you the key, so we share the same key. You use the same key to decrypt it, then you can read it, the message. AES demo is here. So there are some concepts here, like key size and block size. It has some restrictions. So here I have a cipher block. This is the key, 16 bytes. The length of the key is 16, and the block size is 16. So this is the source message, the plain message. So if I encrypt it from desk to source, the key size and block size should be matched. Here is the block size. As you can see, the demo for AES, the block size is 16, and it can be encrypted. So if I change the key size like this, there will be some errors because the size is 15. Okay, this is AES symmetric. RSA is a asymmetric encryption. The difference is the sender and the receiver don't share the private key. For example, if Bob wants to send some information to Alice, Bob has Alice's public key. So Alice has a private key and public key. She gives the public key to Bob. Then Bob uses the public key to encrypt informations, and Alice uses private key to decrypt informations. This is happening every day in our daily work. We use SSH. We paste our public key in server, then we can SSH to the server. But locally, we keep our private key. If you look into your SSH directory, you can see that I don't have our RSA examples here. If you want to check how Golang implemented it, there is a link here. Actually, it's Golang source code. It's a RSA test file. Okay. All right. So that's all for my today's presentation. Hope it's helpful. At least you got a clear picture of the encoding, digest, and encryption. Thank you very much.